One of the things that has fascinated me over the last decade is how connected devices have replaced traditional devices.
It's incredible to see how quickly technology is changing and impacting our lives.
Product design has moved from building costly, time-consuming prototypes to full virtual verification for everything from electrical circuits to PCB and mechanical.
One of the best examples I've seen in my lifetime is our method of communication with the changes in technology. We've gone from a society that sent snail mail to email with the help of a computer. Calling one another has become easier with the ever-improving smartphones, which even gives us the ability to video call virtually anywhere. Now we can even reach others without moving a finger with the smart home devices that have become a norm in the last few years.
A good example is a smart doorbell. A simple button at the front of our houses has turned into a camera that can not only be used to identify visitors, but it can also be used as a security device with alerts that go to our smartphones.
4G LTE technology rolled out over 10 years ago and transformed how we communicate today. 5G is just starting to roll out, which will elevate our ability to communicate, not just between people, but between all devices we use, from transportation to clothes we wear. With 5G operating in the 6 to 100 GHz frequency bands, RF circuits will be part of more than just specialized products.
Hi there, I'm John McMillan, and welcome to this year-end, Make That Decade-End PCB Tech Talk podcast. Wow, 2020 is just around the corner, and as I was reflecting on technology, not just over the past year, but over the past decade, and although we may not be zipping around in flying cars like the Jetsons or blasting off to Mars for a weekend getaway, we've come a long way. Terms like artificial intelligence, augmented reality, Internet of Things are part of our everyday vocabulary. Smartphones can do so much now that we figuratively can't live without them, and we literally get lost without them. Companies are manufacturing electric cars, even self-driving cars. Some have transitioned from companies that we traditionally categorize as specifically automotive companies into technology companies in areas like power consumption, sensors, and electronic connectivity, and more are driving innovation. The emergence of the maker movement and crowdfunding sites have enabled electronics entrepreneurs and hobbyists to create and innovate more than ever, literally kickstarting and shark tanking new products. We witnessed the inventor of the Ring doorbell, for example, pitch his product to sharks, turn down an offer, then go on to sell the company for well over $1 billion to Amazon, and then become a Shark Tank investor himself. From college maker labs equipped with Raspberry Pis and 3D printers to STEM programs in schools, the access to equipment to experiment, create, and make products entered a new era.
The Internet of Things has gone from being a concept to reality. When creating a device, it is almost required now that it be connected in some way, using Wi-Fi or Bluetooth.
Running signal integrity and power integrity checks at every stage of the design process is no longer optional, especially with today's increasingly fast edge rates in our modern ICs.
Creating library elements was sometimes the longest part of a design. Now designers can download components from different sites online in seconds.
Real-time ECAD-MCAD collaboration throughout the design process is now typical practice, and it aids us in avoiding electrical-mechanical conflicts, eliminates some respins, reduces costs, and it can improve schedule predictability.
High-speed electrical design has been around for decades. However, every year we're pushed to design products with more and faster communication channels. As such, our tools have advanced as well, providing automation, simplifying high-speed design.
PCB Design has certainly seen its share of advancements over the decade, and in 2019, the use of electronics in everything is expanding at an exponential rate. Here are some results that may surprise you. During the most recent Aberdeen study, just done in November of 2019, revealed that lower cost products and pressure to meet delivery dates are the top two drivers in PCB design. This is a slight shift from what previously held the top two spots from the previous study, which revealed that time to market and product quality were 1 and 2. The new study goes on to list number 3 was the need for more feature-rich and reliable products, number 4, differentiated products from your competitors, and number 5, reduced development budgets. These were all top drivers to improve PCB design. So, how can you lower product cost and meet delivery dates? Let's talk about that. Let's start with a modern 3D PCB design environment. a design environment that is an aspect of product design wherein the mechanical enclosures, the associated mechanical piece parts, brackets, and heat sinks, and so on, are all collaborated with, essentially creating a digital model of the end product within the CAD environment. So here are some of the tool design technologies that support creating quality, reliable products on time. The first I'll talk about is using Rigid Flex. Yes, Rigid Flex helps solve many new challenging form factor requirements. In fact, more products are requiring both static and dynamic Rigid Flex circuits than ever. And it's actually a double win because Rigid Flex also eliminates mechanical connectors that are prone to mechanical failure. So in addition to being able to meet the form factor requirements for products like smartphones and wearables, you're also improving the performance and reliability of the product. Next up is analysis. In today's high-tech PCB designs, nearly every PCB can benefit from signal integrity simulation and analysis. In fact, it should be a non-negotiable step in every product design process. Signal integrity analysis not only ensures that design constraints meet product performance requirements, but it also prevents you from over-constraining your PCB designs. That's right, over-constraining PCB designs. And SI analysis alone can increase product success by 18% or more. For analog mixed signal circuits, that is, things like behavioral verification, scenario exploration, and component optimization, they're critical to ensuring product design intent, performance, and reliability. Analysis that identifies the signal integrity, power integrity, and EMI-related issues that manual inspection and PCB layout tool electrical DRCs cannot catch is fundamental to product success. So let's switch gears to placement and routing. It's not, can this design phase be reduced? Because the answer is yes, but how? So there are many powerful new and improved PCB design automation capabilities that enable you to place and route printed circuit boards faster and gives you a competitive advantage. For example, planning groups accelerate placement. New routing technologies eliminate the need for manual routing. Advanced trace routing capabilities dramatically decrease routing time. That is, they are specifically designed to address high-speed net routing and accurate trace and group trace tuning challenges quickly. Yes, these capabilities enable you to quickly and successfully complete differential pair routing, those challenging DDR memory interfaces, clocks, the works. My main point here is, when it comes to utilizing the latest and greatest PCB tool features, this is not a place where engineers and designers should become complacent. So, if you're not using advanced techniques for things like high-speed routing and tuning, placement planning groups, design reuse, plane generation, automation, and more, you're essentially letting your competition have a competitive advantage. Next, let's talk about RF for a moment. The number of designs that require RF technology is growing and growing. So is the need for RF-centric PCB design capabilities that can help you accelerate RF layout and routing. With growing 5G challenges, companies that master 5G and 5NR complexities in RF design will accelerate their design cycles, deployment, and time to market. From RF elements to unique routing capabilities, place and route capabilities specifically provided for RF and microwave excels PCB layout and ensures performance. So now imagine you're working with all these things I've just mentioned and ready to go to fab. Wouldn't it be great to have an insurance policy? Avoiding fabrication and assembly issues and the resulting delays when an issue is encountered is a must-have in order to address the pressure in meeting delivery dates. Designs should be fully verified before they hit the production floor, and integrated DFM analysis enables you to do just that. It enables you to identify and correct potential issues. Without DFM analysis, you are essentially leaving potential changes in the fabricator's hands, where the focus is often on increasing fabrication yield, not the electrical performance of the final product. You're essentially putting product schedules at risk, you increase cost, and impact time to market. We've seen a lot of great changes in 2019 and the past decade, and I'm very excited to see all the PCB design advancements coming in 2020 and the next decade.
There have been significant changes in product quality and reliability that are now typically requiring high-level changes in the way you look at the entire product design process. Collaboration and data management are as important as ever.
Rigid flex designs are becoming more prevalent as well. Less room in enclosures means that designers need to get creative when trying to fit more functionality in less space.
The technology advancement we've seen over the past few decades has been astonishing. Cars that can park themselves, devices we can talk to give us information. I have a feeling 5G technology will start connecting objects we've never thought would be useful having electronics on board.
So what are and will be the leading technologies supporting PCB design? According to Aberdeen's study, these are the top 6 leading technologies that will be supporting PCB design. First off is component selection tools that search multiple databases. The second is PCB data management. The third is the ability to download PCB library parts from the web. The fourth is design collaboration tools that support visualization and markup. The fifth is multi-board system design and management. And the sixth is web-based tools for PCB design. According to the recent Aberdeen study I referenced earlier, and I will provide a link to the study in the show notes, respondents ranked the specific actions that you can take today and, as we look towards 2020, that best support the design process. They are: number 1, implementing common design tools and best practices across the company. Number 2 is implementing a strategy to optimize manufacturability. Number 3 is implementing a virtual prototyping and simulation environment to predict design behavior. Number 4 is improving individual designer productivity through tool and process efficiency. Number 5 is improving communication and collaboration with external teams. And number 6 is improving communication and collaboration across R&D. So, do you feel like you're on par with these results? Do any of these study results surprise you or perhaps excite you? You know, from artificial intelligence to augmented reality, the Internet of Things, 5G, DDR5, and beyond, the future of electronics and everything is an exciting, challenging, and competitive industry to be involved in. It's pretty incredible how far electronics products have come in the past decade, and I can only imagine what the next decade holds for electronics design. I'm John McMillan, wishing you season's greetings and a happy new year. And thank you for joining me for this special year-end podcast. Be sure to subscribe to this podcast on iTunes, Spotify, iHeartRadio, Stitcher, or your favorite podcast app. For more information on this podcast, be sure to check out the show notes. There you'll find information related to this podcast along with my email address. So feel free to send me your comments and questions or any topics you'd like to hear me talk about. Or if you'd like to be my guest right here on PCB Tech Talk. Thanks again for listening, and be sure to catch the next episode of PCB Tech Talk.